Okay, the next topic that we're going to talk about is how people actually collect their data and how they choose the people that they are going to survey. That's called sampling techniques. Remember, the sample is the group that we're choosing to interview, the group that we're choosing to observe. Okay, so we're going to be talking about how we're going to get these samples. All right, for data collection. Statisticians use data in many different ways. Now, we are right in the middle of an election, and guys, y'all are bombarded by statistics every day. They might say, um, Winnie the Pooh is ahead of Eeyore in so-and-so polls. Well, I'm going to be honest with you. I don't really know what these polls are because nobody's ever polled me. You have to be very careful about what population they are including in the polls whenever they're giving you information. You got to always consider the source. Data can be used to describe situations. You hear it all the time on the news talking about a certain percentage of citizens are in favor of a certain amendment, or so and so feels safe in their community, or so and so a certain percentage of people support our local police force. You hear it all the time describing current situations. It's not always about numbers and figures. It could be about people's approval ratings or things like that. Data can be collected in a variety of ways, but if the sample data is not collected in an appropriate way, then the data may be so completely useless that no amount of statistical torturing can salvage them. Meaning, there's a certain way that you need to go about collecting your data. Like if I were to ask about the most popular Kylie Jenner lip kit, but I only went to Mr. Mock's first period class, let me tell you this, most of them folks out there aren't going to care what kind of lip kit you got on. Chapstick is going to be their best bet. So we have to be careful who we are including in the study so that we get an accurate representation of people's opinions. Okay? Basic methods of sampling. First one is called random sampling. Now, guys, we use this all the time. If you ever have telemarketers calling your house, they are randomly selecting your number from a list. But there are things called random number generators that crank out numbers all the time. And in this case, each individual subject, it could be human or otherwise, has an equal chance of being selected. Guys, this could be as simple as drawing names from a hat when you know everyone's name is in there and we're just pulling one out. Random sampling, everyone has an equal chance. Okay? Our next method is called systematic sampling, and it's a lot like the name itself, system. You are making a system, you're making a rule for which people you're going to ask. So when you're doing a systematic sample, you are selecting a random starting point, and then every certain number of subject in the population. So for example, if I were to stand at the bridge in the morning and I asked every fourth person that walked past me, should you be able to wear hats inside? I would literally be standing at the door and I would say, number 1, number 2, number 3. Hey, stop, you're number 4. Should you be allowed to wear hats inside? I would get their answer, and then I would start counting over. 1 would pass, 2, 3 would pass. Stop number 4 again. Ask them about hats. Now, they may not necessarily care about getting to wear a hat in the building. I made the rule that I was going to stop every fourth person through the door, and I was going to ask them a question. I made a system for my sample, so I had to stick to that rule, regardless of who it landed on. doing a systematic sample, it's simple to use. It's easy to say, I'm going to ask every fourth person or fifth. You can pick what number. So it's often used. Okay? Next method, convenience sampling. Okay? If you think about the word convenience, a lot of times we hear like a convenience store or things being convenient. They're easy. They are that they just make sense. They're nearby. Convenience sampling is when you just ask people that are easily accessible to you. Like if I were to give you a sampling subject and you just ask the five people next to your chair, that would be convenience because you're just doing the smallest amount of effort. You're just literally saying, hey, you, and just getting their data. You're not out seeking an entire population. You're just grabbing the people closest to you. An example of this could be like if you were using family members or students in a classroom. If I gave you an assignment and you only asked the people that live in your house, or you only asked the people in your group in the classroom, or in your row in the computer lab, that would be a convenient sampling. People that are nearby, that are easy to reach. Um, Another convenient sample would be like mall shoppers. You just ask whoever happens to walk by you. You've all been in a mall, and they all have those salespeople that stop you as you're trying to get out the door, and they're like, "Hey, come try my hair straightener. Hey, come try my hand cream." They are just grabbing whoever happens to walk by. It's a matter of convenience. It's a matter of ease. They just get the ones that are just already there. They are conveniently sampling shoppers because they know you're already there to spend money anyway. Okay, stratified sampling. The word stratified kind of sounds like strategy, where you're making a strategy for the people that you're going to select. So if we're doing a stratified sample, that would be like we divide the population to at least two different groups with common characteristics. Then we draw some subjects from each group. Okay, now that would be like if I were to separate all of the students at Heard County High by their class, freshmen, sophomores, juniors, seniors. We do this during homecoming week, don't we? We separate y'all by class and then we pull 10 from each class to participate in the spirit competitions. Guys, that is a stratified sample. If I pull 10 freshmen, 10 sophomores, 10 juniors, 10 seniors, 10 faculty members, I have divided our entire population into groups based on their class, and then I'm pulling some subjects from every single group. No group gets left out. Then that is called a stratified sample. Stratified sampling is often preferred, even though it's a little bit harder to do, because it does result in a more representative sample. If you look at the example down here at the bottom, yeah, we may have split them up into men and women, but we're getting a whole lot of different people. Like we're getting a lot of different cultures, ages, backgrounds, occupations, everything. You're getting a lot more representative group than if we had just pulled from just one group. Okay, cluster sampling. Okay, we see this a lot of times when they're doing polling for elections. Okay, if you're doing cluster samplings, that means you divide the population into groups called clusters. Then you randomly select some of the groups and collect data from all members of the selected groups. Okay, here's what that would look like. And this is actually used extensively by government and private research organizations. Okay, if we were going to do a survey of people in Georgia, okay, what we would do is we would divide Georgia into counties, That would be our clusters. Counties would be our clusters. We have now effectively split the entire population of Georgia into clusters. Now, to get a cluster sample, you're going to pick a few counties and interview every single person in that county, or collect data from every single person in that county. That would be like us taking the entire state of Georgia, and then we only pull from Heard County, from Coweta County, and from Troup County. We're leaving out all other counties, but we're going to pull Heard, Coweta, and Troup, and we're going to collect data from every single person that lives in those counties. We're going to get data from all three of those clusters. Okay, a lot of times they use these in exit polls. All right, talking about the difference between observational and experimental studies. Just one more time, because this is a very important difference. Okay, you could have an observational study, and that's where the researcher merely observes what is happening or what happened in the past and tries to draw conclusions based on those observations. They are not actively participating. All they're doing is observing what they see and recording it. There is no interaction with the subjects usually, and there's no modifications on subjects, meaning I'm not making somebody do something. I'm not making them participate in something they wouldn't already be doing. It normally occurs in natural settings. Like if I were to observe students, I would probably observe them at school, which is where they would normally be. It can be expensive and it can be time consuming, because it takes a lot of time to actually find people who are specifically already participating in whatever study you're looking for. So it can be time consuming actually seeking out these people without changing anything that people are participating in. An example of an observational study, you could do a survey. You could do cold calls. You could call people at home. You could mail questionnaires. You could do a personal interview. Now, there are different things, different pros and cons for each type of these. Like if you were to do a telephone survey, well, I know as well as you do, when people call your house and it's not a number that you know, a lot of people will not answer the phone when they're called. Or if they answer the phone and they realize that you're just doing a survey, they'll likely hang up on you. So it is kind of a challenge. It's less costly than personal interviews. The tone of voice of the interviewer may influence subjects' responses. You know, some people can be very nice, very friendly on the phone or whatever, or you might get somebody calling your house and they are just deadpan and they are so boring, or they may hate their life and just be like really trying to get you off the phone really fast. So it does have to do with the actual interviewer, the people that are out on the phone making the calls. They might influence the way people react. A mailed questionnaire, it can cover a wider geographic area than telephone calls or personal interviews. And sometimes people don't respond. They might not understand the questions. They might not want to take the time to read it. They might not want to pay for the stamp. They might not check their mail very often. So there are challenges there too. Personal interviews, they're more like one-on-one. They're more costly. Interviewers have to be trained. And the interviewer might be biased in his or her selection of the subjects or the way that they lead them in answering their questions. So there are a few things that we actually have to be very careful of whenever we are conducting surveys. For types of experiments, there's experimental studies, and that's where the researcher manipulates one of the variables and tries to determine how that manipulation influences other variables. So you're actually changing the way one group behaves. You're actually changing a service that one group receives. You are actively participating in this study. Interaction with the subject occurs. Modifications on the subject occur, like you might give one group a Red Bull before taking a test, or you might give one group a Benadryl before taking a test, something that might alter the way that they behave. So this would be an experiment. It may occur in unnatural settings. You might be bringing people in to a lab or into an observation room. They're not necessarily just out in the world going about their everyday business. Sometimes you just have to observe how they act in unnatural settings. For example, they did clinical trials of new medications and treatments. You see these on commercials all the time. And then there's some uses and misuses of statistics. Okay. Statistics can describe your data. It can be used to compare two or more data sets. It can determine if a relationship exists between two variables. It can test a hypothesis or an educated guess. You may have an idea of how people may behave, and then you can collect statistics in order to test these hypotheses. You can use statistics to make estimates about the population characteristics, or you could predict past or future behavior of data. Like right now, we've got people making all sorts of predictions about how the elections are going to pan out. They're using statistics from polls that they have supposedly conducted, and then they were reporting these to the general public to try to give people an idea of how things are going to go. Use of statistics can be impressive to employers. Employers love data. They love numbers, and that shows that, and a lot of times they believe that if you can back it up with numbers, then you know what you're talking about. But we have to be careful how we use statistics so that they actually represent what we want it to represent. Almost all fields of human endeavor benefit from the application of statistical method. However, the misuses of statistics are just as abundant, if not more so. Benjamin Disraeli has said there are three types of lies: lies, big lies, and statistics. So old Benny boy, he was not a big fan of our statistics. It does say figures don't lie, but liars figure. So liars could manipulate the numbers in order to back up their claims. Franklin P. Jones has also said, statistics can be used to support anything, especially statisticians. You can make the numbers say whatever you want them to say. Sources of misuse. Two main sources of misuse could be an evil intent on part of a dishonest researcher. There's some people who are just out to try to make the numbers say what they want them to say. Sometimes it's to hurt someone's reputation or to mislead voters. Sometimes it's unintentional errors or stupidity on part of a researcher who just flat didn't know any better. Sometimes they just didn't account for certain outside factors. In picking your samples, you could have a voluntary response sample, or it's also called a self-selected sample, where subjects decide whether to be included. That would be whether or not people pick up the phone, whether they mail in their answers, whether they call in to a radio station, whether they're participating in an internet poll. Guys, in those, most of the time, that's going to include bias. That's going to include people who already have an opinion. Because if I'm fired up about something, I'm probably going to pick up the phone and make a call. Or I'm more likely to participate in an internet poll or a mail-in poll. If I'm not terribly excited about something and I don't really care, it doesn't affect me one way or another, then I'm probably not going to take the initiative to participate in this kind of stuff. So it does. It has a bias in it. Sometimes you have too small of samples. Sometimes you didn't include enough information or enough people whenever you're doing this stuff. So we have to be careful about the size of our samples. And then inconvenience. If we do convenience samples, those are the ones where you're only asking the people around you. Those are not always representative since the subjects can easily be accessed. You're not including everyone in those. You're just including people who are nearby. Graphs can be very misleading. If you look, like right here on the left side, look at our scale right here. It's by the 10,000s. And if you do, then it looks like California and Nevada, they're pretty close. But if you look at our second graph, it's by 1,000s instead of 10,000s. There's a much bigger gap. Well, they spread that out so that it looks like California has a whole lot more personal income than Nevada, but it's all about how you present it. Graphs can be drawn inappropriately to lead to false conclusions, like the example right here. You have to be careful and watch the scales. Sometimes they won't tell you the units, or they might not give you labels, so then you're not really sure what you're looking at. Or there could be an exaggeration of one increase by another. Okay. Your survey questions could be loaded questions, meaning it has unintentional wording that may lead people to answer your questions in a certain way. Your order of questions, if you're asking a whole lot of questions, people might be paying attention in the beginning, but then towards the end, they're like burned out. They're tired of answering your questions. They're tired of listening to you. They're hungry. They're tired. They might not be quite as responsive. And then you also have non-responsive, which is what a lot of my students are sometimes, where they just flat refuse to answer questions, where they just say, I don't know, and they're just not very useful. There's also self-interest. The sponsor of the survey could enjoy monetary gains from the results. Hey, people get kickbacks all the time. So somebody could be paying a researcher to make the numbers say what they want it to say. That's called a self-interest. They could be doctoring the numbers there. There could be missing data. They may not include all of the people's responses that they have collected. They might only share part of the information. They might not make any comparison. There might be a treatment group, but they may leave out a control group. So they might say, yeah, Red Bull gave him wings. He made a 100, but they may leave out the part that he makes a 100 on everything. You can doctor it. You can make it say what you want to. If you use precise numbers instead of saying 90% of people agree, if you say 92.256%, that means that people might think you're a little more accurate just because you're giving precise numbers. So that can be misleading sometimes. And then sometimes there's implied connections, and that is the confusion between correlation and causality. When we find a statistical association between two variables, we can't conclude that one is the cause of, or that it directly affects the other variable. One popular example of this would be to say that heat in the summer causes people to buy more ice cream. Now, it might be really hot outside, but that's not going to make me buy ice cream. I'm going to be honest, big girl buys ice cream all the time. I don't care what kind of weather it is. More people might buy ice cream maybe because kids are out of school and parents are out trying to entertain them. There could be all sorts of other factors, not necessarily just the weather. Now, the weather could impact it, but it is not the direct cause that people bought ice cream.